A very good morning to all of you. It is my great pleasure and honor to welcome you all to a special lecture on why and how do we do science. Today, we are privileged to have with us one of the most distinguished figures in the scientific community, Professor Veranja Karunarathne, Emerite Professor, Department of Chemistry, University of Veranja. He holds a BSc degree in chemistry from the University of Colombo and a PhD in synthetic organic chemistry from the University of British Columbia. Professor Veranja Karunarathne currently serving as the Vice Chancellor and CEO of the Sri Lanka Technological Campus and also have numerous prestigious positions, including Chairman of the National Science and Technology Commission, Council Member of the National Research Council, and former Head of the Department of Chemistry at the University of Veranja. He has also served as the Chairman of the National Intellectual Property Commission and was a founding science team leader and Associate Director of the Sri Lanka Institute of Nanotechnology. Today, Professor Karunarathne will be sharing his insights on a topic that lies at the very heart of the scientific environment: why and how do we do science? His vast experience and deep understanding of the scientific method make him uniquely qualified to guide us through this subject. Please join me in welcoming Professor Veranja Karunarathne to the stage. Over to you, sir. Thank you very much.
Good morning, all of you. I thought I usually never miss an opportunity to talk to postgrad students with those small crowds. So in that spirit, I thought I'll share some of the reasons why we do research. I use the broad topic science, although I'm a chemist, but it applies to all disciplines of science. Now, who is a scientist is a question that many of you would ask, and I'm sure sometimes your friends, colleagues and parents and relatives ask you, so what do you do when you do a PhD, or why do you do it? Right? So George Bernard Shaw once said that a scientist is in a state of perpetual unbelief and takes no one's word for granted. You should be, if you're not already. That doesn't mean that you should only restrict this to science, but you must believe what your parents tell you and what your boyfriends, girlfriends and husband and wives tell you. But the scientist for science is always that. And he said science is always wrong. It never solves a problem without creating 10 more. So that is the true spirit of science. The moment you discover something, another scientific question arises and you have to address that. And this never ends. You keep going. So when I've seen many people, and I'm sure some of you probably even understand when I say you start with one project and it leads to so many other little things that eventually you end up publishing so many papers than you had originally thought or planned of. And he said ignorance drives science. Because we don't know, it makes everything. Real science is a revision in progress. We always revise what we knew. When a classic example is John Dalton in 1899 or so, in a classical chemistry way, he described that all matter is composed of atoms. Very simple. All he did was he combined oxygen and hydrogen and made water, weighed the oxygen, weighed the hydrogen, weighed the water, and then he realized that there is no loss of weight. So clearly, the fundamental unit, which he called an atom, must be there. So soon thereafter, Rutherford from Cambridge described the atom, but then that model of Rutherford model's atom, which was a far better improvement than John Dalton, a chemist. Rutherford was a physicist, and it was very obvious within a year or two that that model wouldn't work. The electrons circling around the nucleus would lose energy and they would land on the nucleus and the entire universe would be annihilated at a speed unimaginable. No universe would have ever arisen if Rutherford's atom was correct. So then Niels Bohr soon thereafter said that the angular momentum of electron is quantized. So therefore you can never fall, if you take the hydrogen atom, he said it's either negative kilojoules 13 or negative kilojoules 3. It cannot be any value in between. So why? He was asked. He said, don't ask me why. We don't know why it is. But angular momentum is quantized. Otherwise this world would never have, this universe would never have arisen if the angular momentum of electrons around the nucleus was not quantized. So scientists accept that there are only probabilities and not certainties. Right? So we deal with that. And true strength of science is that we put our case to no judge or jury. You've seen court cases that start in all sectors. There are fundamental rights cases, right? But have you ever seen a scientist going to court saying, my reaction is correct and that person's reaction is not correct? Have you ever heard of that? No. You don't take our science to the courts. So we have no judge or jury when it comes to that. And not even rules of evidence. If you start a scientific project, which evidence do you gather first? There are no rules for it. It's up to you to gather the first evidence you like. What do you gather second? It's again up to you. At the end, you collect all the evidences and then you come to a conclusion. Right? So even that there are no rules. So therefore, we must avoid the temptation of becoming a priesthood, falling in love with our findings. I know politicians are fond of saying, my thugs are better than your thugs. But scientists should never say, my science is better than your science. It usually doesn't work out that way. Science is always science, right? So there is no real competition among scientists when it comes to the truth of science. So we are not a priesthood in that sense. We are not wrapped in mystery, competing for belief. We are not religious leaders who say, my religion is right, your religion is inferior to mine. This is what I found out by doing experiments. Maybe it is not correct, but if it is not correct, it could be revised going forwards. So the true strength of science, whether you contemplate the universe from a tree house or whether you look at or observe nature under a tree, or whether you observe the emerging galaxy through a telescope, the true strength of science is we seek, as scientists, we always seek something different to normal so-called laypersons. Actually, laypersons would call us weird people. We are very weird people in that sense. We are not normal people, although we think we are normal. In many sense, the society would describe a scientist as a very different person. So it's like this picture, where in the canopy of animals, it's a giraffe whose head goes above the canopy of the rest of the animals, and we are that giraffe, because we see a world that others don't see. Or we seek to see a world that the others have no access to seeing. So that is who a scientist is. There was a time, like even now, I mean, there are theories of the purpose of life. You know, that question has permeated us over the centuries. Why do humans exist? And there are recent theories which say that we are a computer simulation, left by an advanced civilization from another planet, and we are all in a simulation. But similar to that, 200 to 300 years ago, everybody thought that this is actually a dream. We are in a dream. I am dreaming that I am talking to you, who are you seated in the audience, and you are dreaming that I am talking to you in return. So René Descartes, in 1776, he said, the only true reality is that I doubt everything. That is true. Yeah, I'm doubting whether I'm talking to you and whether this is a dream. And you, in return, may be doubting that you're seeing a dream, me, a person called me, talking to you. So this is like this bird seeing the mirror image on the water, still water, thinking that somehow this is another bird. So that unreality always exists. So when you doubt, you have to be thinking. That's certainly true, right? You can doubt on anything, but the fact that you are doubting means you are thinking. So therefore, he said, cogito ergo sum, I think, therefore I am. So the human condition is described by the fact that we think. Whether we exist or not in reality, whether we are dreaming or not, we are thinking. So that part at least is true. So this should be the motto of all scientists, that I think, therefore I am, and the only true reality is that I doubt everything. So scientific research, soon thereafter, the same, continuing on the topic of this dream, when you dream the impossible dreams and when they come true, and that is true for all students who may be doing postgraduate studies, PhDs, when you start, obviously remember, all of you, the day you started your PhD work, and the journey you go through is so amazing and difficult, and experiences varying every 2 to 3 months, and you becoming, in front of your own eyes, a very different person, and who comes out after 4 to 5 years is a totally different individual who started doing the work 5 years earlier. So, scientists must not believe the reality around him. This is again the dream part that I am talking about. In fact, there was a Chinese sage called Chuang-Tzu, who once said, once I dreamt that I was a butterfly, and now I no longer know whether I'm Chuang-Tzu, who is dreaming that I'm a butterfly, or whether I'm a butterfly who is dreaming that I'm Chuang-Tzu. So anyway, this issue was laid to rest by René Descartes, and I want to shift gears a little bit to the value of teachers. Now, the word science in a Greek root means to organize, is to organize knowledge. That's what the word science means. You go to a chemistry class, you go to a biology class, don't go to a class which teaches both chemistry and biology. You need to organize the knowledge into different little buckets, right? So the teachers organize the young minds into a system of knowledge. That's science. The meaning of the word science is a system of knowledge. The teacher is the bridge always between the student and the scientist, and the student today becomes a teacher tomorrow. So if there are no teachers, no scientists would come forward, and the same scientists who come forward teach the next generation. So that's very important. And Rabindranath Tagore, on this topic, he said, a teacher can never teach unless he is still learning himself. Teacher constantly learns. I taught at the university for decades now, but I still, when I look at my lecture notes in the morning, before I go to the class, I still understand the teaching stuff in a very different light. This can happen to you even after 15 years. So one thing I don't do is, if I see some sparkle light after 15 years of teaching the same thing, I don't go to the class and say that morning, because if I took 15 years to get that spark, I shouldn't burden my student with that knowledge immediately, right? You've got to teachers' value is how much you hold back without telling the student is more valuable sometimes than how much you give the student. And he said, a lamp can never light unless it continues to burn its own flame. Right? So you've got to have your flame burning, otherwise you lose it as a teacher and certainly as a scientist. So institutional goal. All institutions, whether you're teaching institutes or a research institute or a combination of both, you should be research informed, always. Research based, research active, research led, and research intensive. I know these 5 phrases that I've just uttered is not the conversation you are having at your lunch table when you have lunch with your friends, but it's always in the background. This is the elephant in the room. It's there. Although you may not observe it always, nor recognize that this is how I need to act. So the scientific research is in the modern context of science that we do, science is global. There is no Sri Lankan science. If somebody told you that, that's wrong. It's a global science. We follow the scientific method. The entire planet follows the scientific method. It's been a recognized activity for the past 3 to 4 centuries. You remember the story of Isaac Newton in 1600s. He, in front of the Royal Society, his calculations of the status of the planetary system, and he described in a document called the Principia. So around that time, science, modern science, has been doing science the way it is. So Isaac Newton had students, those students had their students, so this activity continued for the last 4 centuries. Now, many stakeholders, you need principal investigators or researchers. I'm sure you all have supervisors. Junior co-workers and support staff are needed, supervisors, administrators, and more importantly, funding agencies. Somebody needs to fund your work. Somebody needs to give the money to do the research. Publishers, editors of journals. When some of you have already begun publishing papers, you know the difficulties of getting papers accepted. And general public, the taxpayers, who eventually are the beneficiaries of the science we do. So basically, many students, postgrad students, will ask, is the topic too broad? Or your supervisor definitely will ask that question from him or herself before giving the topic to you. Can the problem really be investigated? Remember, there are some scientific problems that cannot be investigated, right? Was there a Big Bang 13.8 billion years ago? Probably empirical evidence doesn't exist. You can't do that experiment. So if your PhD supervisor says, investigate whether the Big Bang occurs, maybe that's not a project you should get into, right? So, is the data susceptible to analysis? Sometimes data can be such a gibberish jumble that you can't analyze data, right? So it doesn't make sense. And sometimes, is the problem significant? I mean, in that case, who cares? I mean, it's significant to you, so that's all that matters at the end of the day. Why do we do research? You know, you dedicated yourself to spend 3 to 5 years doing the research topics that you have been given. There is a significant writing task in the work you do. You become a very good writer, you should, at the end of it. Independent and unstructured work tasks, you know, you got to prioritize when you come to work, at least that morning, if not the previous night, you got to prioritize what's the first experiment I need to do today, right? So that prioritizing becomes very important to making progress. And you learn to do something real. That's very important. You know, research skills that you learn, even if you stop doing research after your postgraduate degree, will make you a very competent worker who can work independently by him or herself, and you become an asset to the organization you work, even though you may never do research again. It doesn't matter. You do become an expert on something, especially if you do a PhD. It's the only way to get a PhD. You need to become an expert in what you do, right? Master of a specific subject, completely extend the body of knowledge about the subject, and the key concern with doing research degree are, I'm sure you're already asking students in their 3rd year and beyond, when will this end? Is there an end date to this? I can assure you, many of you who are in the advanced stages of your thesis preparation, that's a very, very apt question to ask. But no sooner than you graduate with your PhD, you will miss all that work you did before. So don't be too hasty to ask that question. let it linger a little longer and enjoy while it lasts. Let me skip this. Your research project and your future career. And like I said, the role of the research topic in deciding your future career, master's thesis, if you do an MPhil, it's minimal. Right? It's an MPhil, you might, even if you do a PhD, you might completely change your area into that. PhD, as much as you want to, as little as you want to. You know, you would just call yourself Dr. So-and-so and be doing some administrative job, not doing research at all. When choosing a research topic, those who will go beyond their PhDs and become teachers, supervisors of students yourself, when choosing research topics, you know, there is no hard and fast rules or guidelines for choosing a research topic for one to do. It should obviously interest you and your advice and the research community, and it should be a real problem, right? And not a toy problem. And it should hopefully be the right problem size. I'm sure some of you are already complaining that your supervisors have given you a project that's too broad. This is going to take 7 years. I'll never leave this IFS for 7, 8, 9 years. This is crazy. I'm sure, you know, you have those internal conversations that you never will divulge to your supervisor, that how unfair life has been to you, that you have got this project, right? So research grants are important. I'm sure your supervisors occasionally trouble themselves about finding money to fund your research. There is a little cartoon here. I asked Santa, like in Christmas, for a research grant. So the other colleague is saying, do you still believe in Santa? You know, it's not an easy thing to get into grant. Now, these two scientists on the right-hand side are saying, if we get this grant, we might be able to afford a real microscope, not a magnifying glass. So, you know, this is always a troubling area of research, how to find money, and in a country such as Sri Lanka, where 0.15% of the GDP is allocated for research funding, primarily coming through your institutional money, and if it is an external agency, it could be something like National Science Foundation or National Research Council, but there is really very little else if you are doing fundamental science. So money is never easy to come by. Now, science is shared knowledge based on a common understanding of some aspect of the physical and social world. So it is shared knowledge, meaning that you need to publish this work. That's how you share it, right? So the publications in peer-reviewed journals, that's a phrase you have heard many times, right? You can see this path. So the guy who is publishing is running along that tarmac with his manuscript, and there are many people who are waiting to hit, kill or maim the person before he gets to the point where a publication is accepted. Particularly in a country like Sri Lanka, with the address from Sri Lanka, publishing is even harder. I'll come to that topic later. Now, how do we evaluate and determine the impact of these publications? Publications are important. Now, a paper or a research publication is an organized description of a hypothesis, data, conclusions intended to instruct the reader. If your research does not generate papers, unfortunately, it might just as well not have been done. If it wasn't published, it wasn't done. So that's how important publications are, right? So you don't want to dabble in something that eventually has really no place where it is recorded that you have done the work. The writing process is a very inexact art. You learn and identify your own strengths and then continue writing along those strengths, and your supervisors can correct you, they will correct you. Now, actively seek out critical readers, your co-authors, your peers, Provide comments on your drafts. Remember, you don't know it all if you are a novice writing your first paper. And try to anticipate the points of criticisms from reviewers. Remember, when you send a paper for publication, if you're lucky that the editors would send it for review. Sometimes 50% of the time editors don't send it for review. They just send it back rejecting the submitted article. So if you're lucky that it goes for review, then you have to anticipate what problems the reviewers will ask you, right? What are the areas, because you are the one who knows all about your research. And for example, your first article, you will probably write 15 drafts. That's not uncommon, right? Your supervisor will send you back and forth until you get things perfect. And your best articles will have 5 to 10 rejections. Always remember this. This is not an easy game, right? In the good old days, now of course they come, your acceptance or rejections come through email. There was a time when I was much younger than this. They used to come through mail, right? So the moment I see the envelope, the mail coming from a journal, I pour a glass of water and sit on a chair. Because some of the comments reviewers write can be brutal. You can, if you don't have a strong heart, you will give up research after you read the comments the reviewers send you. But the good thing about humans is after the papers are published and all forgotten, we have a way, our mind has a way of forgetting our bad memories. We only remember good memories, fortunately. If we remember our bad memories, we would certainly die quicker than we normally do. So, you forget all this, but this is the status of articles, right? Now, this is the other question. You're at least familiar. There's a Google watches you. Google watches all scientists who publish their work. And then they compile, and there's a person called Hirsch who came up with a Hirsch index or the H index. H index, a scholar with an H index of H has published H papers with at least H citations each. So if you have H index of 10, you have published 10 papers which are cited 10 times or more. So this, there are variations depending on the field. People in medicine, particularly in Sri Lanka, their papers get cited more than people who do hard science. Because most of the medicine papers coming out of this country are considered tropical medicine, and tropical medicine has a limited geographical area, only in the tropics. But if you publish in physics, chemistry or biology, there's nothing called tropical chemistry, tropical biology or tropical physics. You're competing with the global scientific community. So then, you don't get cited more. So if I am the writer, or let's say I live in England, I have to give a citation for, in my paper, a reference, right? So I have two. One from Sri Lanka, one from the US. Very likely that person is going to choose the publication from the US and not from Sri Lanka. So not only are scientists disadvantaged because science is truly universal, and you have to compete with the global community of physicists, chemists or biologists. Not only that, but also papers with the Sri Lankan address tend to get cited less. Which is a reality that you have to live with. What Hirsch said, what should be a good H index? He said, Hirsch's definition, so not mine. He said, in his opinion, 20 H index is good, 40 is outstanding, and 60 is exceptional. But after 20 years of research, no one is going to get a H index of 60 in 2 days. Doesn't work. So if you have been a researcher who has worked for 20 years, these would be acceptable. But he further pointed out that approximately 84% of the physicists who received Nobel Prizes had a reasonably moderate H index of 30 or less. So this is not the ultimate indicator of how good your work is, right? So you have to put it in perspective. And then, these are basically comparing apples and oranges. If you compare articles of one discipline to articles of another discipline, for example, research articles and review articles and case studies. Those are the three types we have. Now, review articles get cited way more than most articles. Case reports mostly come from the medical field. They get cited. But research articles are tough to get citations for. Disciplinary cultures are there. If you compare history versus immunology, there are major differences in the citation impact. For example, New England Journal of Medicine, this data is sometime back, has a very high impact factor. Lancet, which is another medical journal, high chemical reviews, high. If you take Nature Reviews Cancer, very high impact factor. Our own Journal of National Science Foundation, if this 0.5 is not accurate today, it's no more than 0.75 today. So it's a very low impact factor for our own, just one index journal in this country. Right? That's the only place. There's a thing called the Matthew effect. I don't know how many of you have heard of the Matthew effect, but you have certainly heard of the phrase, the rich gets richer and the poor gets poorer. Now that doesn't only apply to money that you have in your pocket or in your bank account. That is certainly true. If you have more money in your bank account, you get richer quicker than if you have less money in your bank account. That's a global phenomenon that the way the world, the rules of the world are made by rich people. So the poor people have to abide by the rules made by the rich people. So the rich are highly, in a very advantageous position. So this is like a centrifugal effect. High-ranking journals' rankings are self-perpetuating, right? Hard for new journals to break into high rankings. Journal of National Science Foundation is a classic example. Very difficult because the journals coming from first world countries, more advanced countries, it's self-perpetuating impact factors for these journals, right? Good scientists published in these journals, so therefore they have a high impact factor that continues. So, I mean, we are saddled with all this. And non-English language papers, there are Chinese, sometimes Portuguese, from Brazil. These get cited very little actually, right? Because who bothers to do a Google Translate and read the paper that he published in French, German, or Chinese? So the Matthew effect basically means those who have power and economic and social capital, those who have power and economic and social capital can use those resources to gain more power and more capital. That's Matthew effect. That's how rich gets richer and poor gets poorer. Now science has always been international. I want to come to this point. There is no Sri Lankan science, I told that to you before. However, doing science in Sri Lanka is not easy. That is true. Now this cartoon series, I'm sure many of you research students have never seen the cartoon series called Peanuts. That's when I was your age. That they had not in Sri Lanka, but it was an internationally known cartoon series called Peanuts. So here, Peanuts has submitted an article to a journal and he has got a letter. I told you how difficult it is to read letters that you get from publishers. So, so the publishers have written to him, thank you for submitting your story to our magazine. Thank you for submitting your story to our magazine. To save time, we are enclosing 2 rejection slips. One for this article and one for the next one you submit. So this is the status that we are in as Sri Lankans who want to publish. So that doesn't mean that Sri Lankan scientists have not broken the barriers and published in good journals. They have. They do very often, but it's always a struggle. Sometimes many drop out of this process and many give up doing scientific research altogether. So my definition of having been doing science for a long time, you know, at what stage can you say, I'm a scientist? Now remember, scientists, this is a priesthood. You are part of a priesthood. You have to first understand that. So any priest of any religion, when does he reach a stage that he will never return back to being a layperson again? How long does it take? So similarly, if you are members of a priesthood, how long does it take for you to say, now I cannot become a layperson, I'm a scientist forever? My definition is, it could be wrong, it could be based on the discipline, but at least based on what I think, if you one day publish 10 papers, maybe beyond your PhD, you may not publish 10 papers for your PhD, but beyond after that, you will probably reach the point of no return. You cannot go back and become a layperson again. So that's when you will continue and to do scientific research very likely till your last days. And that's very important for a country to have that kind of people who are sustainably engaged in scientific research, right? Now there is scientific misconduct. Some research behaviors are so opposed to the core principles of science that they can be treated harshly by the scientific community. Fabrication or making up data results. There was a big news story of a Sri Lankan scientist in the US having to retract his papers in very prestigious journals published because he's been cooking data, right? Falsification is manipulating research materials, equipment and processes are changing or omitting data or results in such a manner research is not accurately represented to the scientific world. And plagiarism is also another problem. The appropriation of another person's ideas, processes, results and words without giving appropriate credit. So this is an article that had to be retracted. It's a single cell imprinting on the surface of a silver zinc oxide bimetallic nanoparticle. Right? So this paper, having been published in a journal called Biosensors and Bioelectronics, it was retracted after complaints. Right? So, you know, it's very important that honestly, truthfully, you present your material. Plagiarism has many aspects to it. It's a different aspect of scientific misconduct. Copying your own work can be considered plagiarism sometimes. If you published a paper by yourself, and if you're publishing another paper, you have to accurately recognize the work in your own paper. Right? So that still can be plagiarism. There are many areas where plagiarism can be measured, but I think you know what I mean, and it's important. These days, no paper is ever published, especially review articles, without going through a plagiarism check. You know, nothing is accepted, but research articles generally, the only places where plagiarism can happen is in the introduction. But because you're describing your own work, you probably won't plagiarize in the discussion and materials and method. Science at all times should follow truth. We discussed that. The classic story is the story of DNA. As you know, Watson and Crick were awarded the Nobel Prize a few years after the Nature publication of the double helix nature of DNA. Very quickly recognized. One of the most seminal, important work. But Watson, who was a postdoc here, he had the advantage. Now, at the same time, there was another scientist called Rosalind Franklin, who unfortunately died before this Nobel Prize was awarded, of breast cancer. She was doing X-ray work, X-ray crystallography of bovine blood, of cow's blood. And this famous picture on the top right-hand corner, you can Google that anytime, which clearly indicated what the X-ray was showing was a double helix, was available to Watson and Crick. Now, Watson and Crick came up with the double helix not by doing experiments. They didn't do any experiments. They just surmised. They thought that this should be the structure, and clearly Watson published the paper, and next to that paper was Rosalind Franklin's paper in Nature. As you can see, the structure of deoxyribonucleic acid, Watson and Crick. The same year, April, James Watson, Crick first described it, and Rosalind Franklin's paper appeared in the same year. Molecular configuration in sodium thionucleates. So they appeared like papers which the authors didn't know what the other one was doing, and that was not true. Watson had seen Rosalind's famous X-ray picture of the double helix. So, of course, it was discovered if Rosalind Franklin had lived until the Nobel Prize was given, she would have been the third person to have got the Nobel Prize. But then, unfortunately, she had died by that time. So, of all the crimes we can commit, the worst is to steal somebody's glory. The worst is to steal somebody's glory of everything else we can do. Fred Sanger said about these things, there are so many journals publishing articles these days. In these, there was a good deal of omission and simplification. And he said, also, that with the passage of time, even I find myself accepting such simplified accounts. This is something that we all succumb to, and as you can see, many things still remain mysterious. Right now, I firstly alluded to, in the beginning of my talk, why is the electron angular momentum quantized? It's been now almost 80 years since Niels Bohr said it in a conference in Copenhagen, which is still referred to as the Copenhagen interpretation of quantum mechanics. It's still the same. We are 80 years after that conference. We still don't know the real reason why the angular momentum is quantized. We know it is. We know a lot of facts behind it. We have used it. Today's technology is filled with that understanding that angular momentum is quantized, right? But we still have gaps to fill, and that will continue. And the truth we perceive, what he's talking about here, is about being scientifically truthful and honest about what we do. And when you are dishonest, the first person to know that you are dishonest is you. Before others discover that you're being dishonest, you know it yourself. So what are the incentives for doing science? So I don't know how many of you have heard about a candle problem. This is a very famous problem called the candle problem. It was introduced in 1945 to understand that we have what are called cognitive biases. The cognitive bias is, one good example is you are seated on a chair. You think the chair is only to sit down. So you're biased that the chair's purpose is for you to sit down. But there could be other functions of the chair, but you're not thinking of it. So this candle problem is, there is a box of thumbtacks. Thumbtacks are the little nails that you stick paper on a notice board, and a candle and a box of matches, and you are asked, can you light the candle and fix it to the vertical wall behind the box? Fix it to the vertical wall. So many people, they lit the candle, burned the bottom of the candle, and melted the wax and tried to put it, it fell down. That is because, and then no one thought of what to do with the box. They couldn't think. They thought the thumbtacks are in the box because box is there to keep the thumbtacks. You bias towards it. When I give you the solution, you take the thumbtacks out of the box and then you fix the box to the wall using the thumbtacks, light the candle and fix it there. So this candle problem, I mean, that's a solution to the problem, right? That's because you got out of your framework of thinking that the box is only to carry the thumbtacks, right? Not to hold your candle. So this, the importance of this is later, much later, this came about in 1945. In the 1960s, somebody gave this to two sets of people. To one set of 5 people, the problem was, can you solve the problem? Anyone solving the problem the fastest will get $100. Independently, to the other group, the same researcher said, just solve the problem. You know, you just want to find the median time that a person takes to solve this problem. Don't be stressed, just do it. So do you think, what do you think, who do you think won the competition? Was it the group that were given a financial incentive, or was it the group that was empowered to think freely? It's the latter group that were empowered to think freely who won the competition. So if you always dangle the carrot of money to a researcher, you know, it kills your creative thinking. Although it's counterintuitive that money is not an incentive, money is an incentive. But money, incentivity of money is not everything. Freedom to do your work is the real incentive, according to the candle problem. Now we talk much about the research culture, so to speak. I'll talk a little bit about this. You know, the research culture is the framework upon which we build our research. We should have a culture, we should have rules. That's very important. And Latin, we call it cultura, the whole product of an individual, group or society of intelligent beings. It includes technology, art, science and moral system. So it's that structure upon which everything is built. Now these are a group of, the picture shows you a group of Maasai warriors. The tallest person, who is the tallest person in this bunch? What's his function? He's a leader. Why did they select the tallest person as the leader? Because he can see far. He can see animals coming to attack them. So in our institution, do we choose the tallest person to lead our institutions? Who has the vision, the foresight and the ability to see far? Most often than not, we don't. And that's one of the reasons why some of our institutes are crumbling. Now, the important thing about research culture is that this cannot be achieved quickly or easily. Culture is very important. It's going to be as slow as the decline would be if we do nothing. So the rate of improvement of research culture is equal to the rate of decline if you don't have a research culture, and sometimes we can't tell these two things apart. So if I quit now, I will soon be back to where I started, and when I started, I was desperately wishing to be where I am now. So that's the truth of it. So I will stop this talk. Sure, you have to go back to the labs with defining the meaning of the word hurdle to you. You know, everything is a hurdle. We jump at least one hurdle every day. Before you go home, you can write on a little notebook, what is the hurdle you had to jump in the lab today. Randy Pauch, who died at the age of 40, who was a computer science academic in the state of Massachusetts in the US. He was dying of liver cancer. So he decided to write a book called to his children and to posterity, where he defined the meaning of the word hurdle. He said brick walls, which we normally consider hurdles, are there for a reason. Brick walls are not there to keep us out. Brick walls are there to give us a chance to how badly we want to achieve something. Because the brick walls are there to stop the people who don't want it badly enough. And they are there to stop other people and not you. Remember, all of a sudden, I'm sure you have experienced, many of you, bunch of people competing with each other, jostling, pushing, and there is a hurdle in front of you. And all of a sudden, you find, you look around, all the other people have vanished. You're the only one who has jumped the hurdle. Because you really wanted to jump badly that hurdle, right? So, therefore, I want you to understand, if you need to jump any hurdle, and if you jump it, that means you really wanted to jump that hurdle. So, don't hesitate to jump hurdles, try hardest, and win the race. Every day is a struggle. We all struggle. I still struggle. I still publish. I still wake up in the night to read papers. It never ends. So, this may be the beginning years for you, but make it truly work for you so that it continues for a long time. Thank you. Thank you very much.